All right. So we're looking at this graph here. That should be the one that you guys have. And got a few questions about the intercepts and the slope, things like that. So first question is, what is the x-intercept?
Hours of travel? Number of hours traveled.
So x is the number of hours traveled, but the intercept is a very specific place. It's about 10.5. It's where my graph crosses my x-axis. So the x-intercept is the point 10.5 or 10.5, however you want to word it, comma 0. So our xy. What is that? 10.5 what, 0 what? The trip's done. I have 0 miles remaining. I have 0 distance left. So the whole trip took how many hours? 10.5 hours. The x-intercept is when my line hits zeros. It's that there are 0 remaining distance or remaining miles. 0 miles left. That's an M. At 10.5 hours. I know I don't have much space. Yeah, it's okay. Y'all don't have lines anyway. So where might the y-intercept be?
685.
It is. And if we look in the story, it's like this up here above 650 thing. If you look at the story up at the top where they talk about her going from Nashville to Orlando, it's at 685. That's the miles. So 685 total miles. So if we put this as an ordered pair, what's it going to be? 0 to 685. So what does that mean? 0 what? 685 what? Miles to go at 0 hours. So it's how many miles she has to go from the start. So at 0 hours, that's why most people don't drive to Disney. I mean, a lot of people do, but that's a long time. Driving to Florida. Well, that's also if you're going 65 miles an hour. 0 hours, that comma's in the wrong spot. There are 685 miles to go. All right, so now we have some different pieces here. A couple of pieces are, what is the slope and what does it mean? So what is the slope of this? 65. So if you look in the paragraph again, it has that equation of D equals 685 minus 65 H. So our slope is it 65 like this? Or is it negative? It's negative. We can also see that looking at our line here. It's going down. It's falling. What does the negative mean in terms of this? Why is it negative on this trip? Because we're counting down. If she was saying how many miles I have driven, like it would probably go up because she's driving more and more and more miles. But since she's counting down because she's like, I'm really excited, I want to go to Disney. There's 600 miles to go, 500 miles to go. Rah! Doing that. She's counting down, so it's going down 65. Down 65 what? Down 65 miles per hour. You can think of it in terms of our change in our rise over run, change in Y's over the change in x's. So it's 65 miles per 1 hour. Though I just did 2 hours, but that's okay. So it's down 65 miles per 1 hour, down 65 miles per 1 hour. So miles per hour is a slope. And then we've got a couple of weird questions here that are like kind of awkward in this particular situation. Is the domain and range? What is the domain? In general, what does domain talk about? The x's. So in this case, we're looking for our smallest x and our biggest x. What is the smallest x we have in this function? 0. Because I cannot travel negative hours, because that's going backwards in time. Yes, domain and range. So 0's our smallest. What's our biggest? 10.5. It's all about the smallest piece we can have and the biggest piece we can have. We're not going to do tons with domain and range, but it's just looking at how far left we go, how far right we go. Domain and range will come up a little bit more when we get into like quadratics and things, but just kind of remembering some of those things that we've learned before. How about our range? What are we going to put for our range? So we're at 685 is a part of it, and 0. What order we put things in for domain and range? Do we remember? As if we're thinking ordered pairs. Smallest to biggest. So this is our tippy top. This is our very bottom. So this goes from 0 to 685. And this particular function does not have, like, a lot of times you write these as negative infinity, positive infinity, those kind of guys. But since this is a real world situation, I'm not going to have negative infinity hours or negative infinity miles either. So when we're dealing with real world situations, we're not as often going to do domain and range, but it's one of those things that'll come up every now and then. So putting slope and the intercepts in context, we are going to use those quite a bit. We're going to do a lot of story problems and a lot of putting things into context. So we've read a lot of these things on the graph. The next thing we're going to do is we're actually going to look at a graph that we're going to make. So we're going to look at page 13, I think. Yes, mine's 15. It should say exit ticket graphing in context at the top. Oh, 15. It's entirely possible. Called I haven't updated the page numbers in a couple of years. Oh, yes. This is where the page numbers do start to get a little weird. So looking at the big number, page 13, because the outside numbers both say 14, because copying is fun. And I totally noticed that in the proof that they sent me. Totally noticed the page numbers get weird. So we're only going to look at those big numbers. We're on page 13. This one looks like this. So we've got the Carol Oates T-shirt company, where she both designs and makes the T-shirts. She paid $18,000 for a very special printing machine. And it costs $5 to make each T-shirt. So we have this equation that her cost equals $18,000 plus 5T. This is the equation that we have in the book as well. So, first question I have is, what is the y-intercept? 18,000 is our y-intercept. How do we know that that's our y-intercept in the equation? It's how much you paid from the machine. What kind of function is this? What's it going to look like? It's a line. This is linear. So this is very much following that y equals mx plus b situation. So why is my y-intercept not 5? Because that has a variable. The m always goes with the variable. This is my variable. So even though they're flip-flopped, this is still my mx, my slope. So 1800 is my y-intercept, and I heard you guys say it right when I said that. It's how much she paid for the machine. It's her starting costs. It's what she started with. Starting cost. And then what is our slope? Yeah, so we're looking at that 5t piece, and the slope is the 5. So 5 what's? What does it mean in context? $5. Slope is always going to involve a per, so $5 per what? Per shirt. So every shirt she makes costs her another $5 to make it, $5 to make it, $5 to make it. So every single shirt. So if we're going to come and graph this, where are we going to start? Where's the first place we're going to look to make a graph here? We're going to start at the 1800. It's the amount. So if she makes no shirts, her company has spent $18,000. So she makes no shirts. She just buys the stuff and then decides, you know what? I'm out. I don't want to do this anymore. I'm not having fun. Outie. I don't recommend it, but some businesses that happens. But she still paid the $18,000 to buy the machine. What do we do to find the next place to put a point? What do I do with my slope of 5? So you notice something here. This is not counting by ones. This is counting by 100s. And this is not counting by ones or 100s. This is counting by 2000s. So when we have weird scales, pick some points to find values for. Because I can't just do 5 up, 1 over like we would normally do in an old school graph. Like if I was counting by ones, we would do our up 5 over 1, rise over run. Since these are counting by different amounts, that's not going to work. We have to actually figure it out. So if I look at purchasing 100 shirts or producing 100 shirts, how much would that cost for her to produce 100 shirts? What's up? Oh, there we go. Thank you. Probably don't touch the screen enough. So it would cost $500 to make the shirts total. So how much would she be out money-wise? So it would be the $18,000 plus the 500. So for 100, her costs are right around here at that 18,500. That's what this is. And I know it's super tiny right there. And this was their 500 plus the 1800. So you can do this by either lodging it through the way we did, or we can take the equation, this guy right here, and just substitute pieces in. Substitute in our 200 for the t-shirts, or the 300, or the 400, and substitute it into our original equation. That's another absolutely valid way to do it. This is the way you guys kind of talked it through. But we could also take our 1800 plus 5 times and put in that 200. Picking an X from my table down here. Yeah, so this would be the 1,000. And then we have our $18 plus 1,000. And so for 200 shirts, it's going to cost 1,900, which is right in the middle here. So when there are weird units, we do need to be careful. So it's going to count up like this as we're going. To make our graph. So the more shirts she makes, the more she is spending money. So hopefully she's sending them at these selling these at a pretty decent clip. I am so good at drawing straight lines. Oh my gosh. It's beautiful. I'm so good at it. Okay, so reading equations and being able to make a graph from the equation is what we're going to work on continuing forward, we're going to look at analyzing stories to try and find those pieces. I do have another little activity for you to do, practicing identifying these features and putting them into context, and it's actually on Desmos. So you can either go on the Canvas page in the module, there's a link to the Desmos activity, or you can go, and I think it works okay on your phone. It's not fantastic, but it does work okay. But if you got your computer, it'll work way, way, way better on student.desmos.com with this access code, or you can do /join/the access code, either way. But that's what we're going to work on for the rest of it. You're going to be matching your characteristics to the graphs to the equations, kind of working on trying to do a matchy thing. I'm 95% sure this is the one that looks kind of like matching stuff. Okay, so that's what we're going to work on. We're going to practice identifying those features, recognizing those pieces and how they connect together. And this is the last thing for me for you today. So you're going to do these, and I want to say there's like 7 pages for it on Canvas, or on Desmos. So it's not tons and tons and tons. Awesome. So it's not tons and tons and tons, but I want you to work through it, see what we can do with it. Feel free to ask questions. Again, I'm more than happy to help you. I'm just going to pull it up so we can see it. And you don't necessarily have to log in with Google. You can, except it no longer has to be a guest. So yes, you do log in with your school Google. And you're going to match them up. So you're matching your X, Y intercepts, because it should be something that looks, oh, is it being locked? Shouldn't be, because I just signed in as a student here. Because you're going to just like kind of match these up. So you have an equation, you have X, Y intercepts, you're going to try and match up the pictures. Let me see. If it gave you the invalid access code, if you type in the code, it should work just fine. But let me go to my side and see if I can figure out what's going on. Or is it the Canvas page that says locked? From Canvas or from Desmos? Desmos, okay. That's going up. It should be working. It's showing it as active, so let me pull up the student page. Alright. Yeah, you should have, if you go students.desmos.com, if for some reason the link's not working, type in access code DZCGYZ. I don't know why it's being a grumpus, but it is. What's up? Oh, that's what, okay. Weird. Usually they'll, okay, never mind. They used to have be a guest and you didn't have to do that. Love that Desmos is locked out. That's fun. What's up? Yeah, give me a second. Fun times. So never mind, I guess we're not doing a Desmos activity. And I will send a message to tech because they should not have Desmos blocked. Love that. So much fun. I love when they change settings on me. It's so much fun. I love it so, so much. Alright. Where's that? Okay. Alright. Well then, push on to that. Okay, never mind then. Oh, well, we'll just deal with it. We'll just have done it on those 2 pages. It wasn't too extravagant. It was just matching those things up. But that's good to know.